But for our second video, we're going to look at what makes up all of our minerals. We're going to look at a very small microscopic level at the different particles that are inside of an atom. So we see that everything on our planet, whether it's the air we breathe, the water we drink, or in the car that we're driving, everything is made up of atoms. And atoms is just the smallest particle on our planet that can't be chemically split into smaller particles. And we're going to see that atoms contain three major particles inside of them. And these are going to be protons, neutrons, and electrons. And oddly enough, we're going to see that all atoms that exist on our planet formed from a star and nuclear fusion. So you might have heard that famous saying, we're all made of star stuff. It's actually true. Nuclear fusion, forming stars, has created all the atoms on our planet. But when we're looking at what makes up our atoms, we're looking again at those three small particles: protons, neutrons, and electrons. We're going to see that protons and neutrons have nearly identical masses. This means that they take up about the same amount of space and weigh about the same as each other. But electrons are very different. They are incredibly tiny. They're about 1/2000th of the size of a proton or a neutron. And because they're so tiny, they have very little weight associated with them. But we also see that in a difference to their mass, how much space and how much they weigh, all of these particles are different based on their electrical charges. Neutrons are neutral. They have no electrical charge at all. But protons have a positive charge of +1, and electrons have a negative charge of -1. So when we're looking at diagrams of atoms, we might be more accustomed to seeing this diagram on the left, where we have a nucleus at the center, where those protons and neutrons that are taking up space and they have weight due to their mass are at the center, and we have electrons floating around these kind of rings around them. But this isn't actually the case. When we look at atoms under a more powerful microscope, what we see is that, again, inside of our nucleus, we have our protons and neutrons, but the electrons don't really orbit them in rings. Instead, they surround the nucleus kind of like different layers of a cloud. And we can see that there will be different numbers of electrons in each layer of our clouds. So when we look at these electron clouds that surround the nucleus, we're going to see that each different layer of that cloud we're actually going to call a principal shell. And each principal shell is going to be capable of holding differing numbers of electrons. And remember, electrons are those tiny, almost weightless particles with a negative charge. But what we're going to be mostly concerned about is called the valence electrons. And this is going to be the outermost shell of our electron cloud. We're going to see that as our atom adds more and more electrons, each different layer or shell of that cloud can only hold a certain number of electrons. The very first shell around our nucleus can only hold 2. But as we move outwards, each other shell is going to be capable of holding up to 8 electrons. And this outermost shell, again called our valence electrons, wants to get up to 8 electrons within that cloud. And in order to get that number of 8, it's going to interact with the other valence electrons of other atoms and start forming chemical bonds, or just attaching to other atoms to build bigger and bigger particles. We also need to be aware of the protons in an atom as well. And remember, protons are those larger, heavier particles inside of the nucleus with a positive charge. And the first thing that we want to know about an atom is what its atomic number is. and the atomic number is just the number of protons inside of the nucleus. And if we start changing the number of protons inside the nucleus, we'll actually be changing what element we're looking at, just by changing one particle. So for example, if we're looking at an atom with 6 protons inside of the nucleus, it would have an atomic number of 6. Looking at the periodic table, that would be carbon. But if we add just one more proton to the nucleus, it's going to change the atomic number to 7, and now we're looking at the element nitrogen. And looking at all of these different elements inside of our planet, we have about 90 naturally occurring elements on Earth. There are more than this on the periodic table, but these are man-made elements. But together, all of these elements are arranged on our handy-dandy periodic table. And each column of our periodic table are going to share very similar chemical properties, and this is going to become important in our next video. But we're going to see that most minerals are made up of chemical compounds. So we don't generally just have one element inside of a mineral. Instead, we have multiple atoms of different elements chemically bonded together to form a mineral. But we are going to see the rare occasions that we have some minerals that are only made up out of one element. And we call these minerals native minerals. Sometimes native metals, because they're typically our metallic elements. But they're going to be things that are rare in nature and generally have a pretty high cost or profit associated with them. Things like gold, copper, and silver.